I'm Praveen Chitrada, Senior Manager in Akamai Technologies. I work for the team NetStats, which is Network Statistics Engine, which is responsible to calculate statistics on our deployed networks, which are used for billing, forecasting. We also build statistics for cost for goods sold as well, considering depreciation cost, co-location cost, and all those. So I manage all the technical resources on the team. Just a brief introduction on me. So let's go on to the introduction about Akamai. I'm hoping that most of you guys know about Akamai, but Akamai makes internet faster, intelligent, and secure. Keep digital experience closer to users, and obviously keep attacks farther away. Our history is that it was founded in 1998 as part of rooted in MIT technology. Some of the corporate stats: 2.71 billion revenue as per 2018. We have more than 8,000 employees, and 5,000 customers. We have close to 240K edge servers in 1,300 locations around the world. So, Akamai state of internet, as I explained, we have close to 240K servers around the world. We see at any point of time 15 to 30% of internet traffic goes through our deployed networks. Some of the metrics just to share here is that we see close to 1 million page views per second. We see close to 12 million hits per second. This March, we have a peak of 82 terabytes streaming per second. And we also see close to 185 million attacks per day on our network. So let's go through the agenda for this presentation. Obviously, we're going to go through the stack that we have and the use cases we have, and problem statement and the goals for the newer architecture. And we're going to talk about how we scale with MemSQL, a high-level architecture after that, how we operationalize the whole application using Airflow. And obviously, this cluster is used, so how do we monitor the cluster? We have used Prometheus for that. And obviously, containerizing the application stack using Docker. Future enhancements on track. And at the end, we'll have a Q&A. So I appreciate if you guys keep your questions for the end, and we'll go through that. Okay, as I said, NSE stands for Network Statistics Engine. We have two use cases. One is Prism, which is an intelligent platform on big data, which detects trends and anomalies, which is used for any revenue retention or generate opportunities based on the trends and anomalies that we see for customer traffic. For this use case, obviously, we use MemSQL as a data store. Grafana connects to MemSQL to visualize the data. MuleSoft as an API layer to publish data to downstream consumers. We use a little bit of Node.js for the backend purpose. Oracle Data Integrator, ODI, for data interface to publish datasets, use datasets. And Spark is a little bit of ML running on Spark cluster to detect trends and anomalies, right? The other use case is network statistics. This is a use case that we're going to discuss for the whole presentation. It's a batch process that calculates usage metrics on deployed networks at contract level, customer user ID level, product transport layer, that's egress, ingress, midgress, traffic types, could be HTTP, HTTPS, ESSL, country level, geo level, customer to customer, partner level stats. So you can see the magnitude of how many usage metrics we generate. We also do cost for goods sold. That's considered, as I said, co-location costs, bandwidth costs, and server depreciations to figure out how much it costs Akamai to serve traffic to customer. With that, we can figure out what is the profitability. So these stats in turn used by invoicing, forecasting, revenue sharing, profitability, internal and external customer analytics, and usage reports. Again, here MemSQL is used as a database and a data store for us. We use MuleSoft as an API layer as well, Docker as a containerization engine for us, ODI for data publish, and obviously Airflow as a workflow engine and the controller for us. So I want to go with the problem statement. The legacy database not able to scale to exponential data ingest needs, and the batch process is not able to meet ever demanding SLAs that we have. Even the legacy code implementation is complex to support and enhance. Even it takes a lot of time to debug any issues on the current legacy database. So some of the goals we have set for the newer architecture, obviously batch process is not the future, so we want to go to near real-time statistics. We want the platform to be scalable, obviously application to be simple and supportable, and at the same time we want the whole stack should be cost efficient as well. Scalable ingest is very critical here because, as I said, we have 240K edge servers around the world that tends to generate more than 129 trillion events on the edge. Right now, we don't need 129 trillion events to build customers. We ask our upstream system to aggregate at a 5-minute level. That said, it's not stopping us to get those real-time events as well. So we definitely want a scalable ingest platform. And we want to make, even before going to real-time analytics, we want to make a 10x process improvement as we are having 13x more data on the horizon. Again, the current legacy implementation is active-passive. Obviously, the industry is moving towards active-active, so we want to make use of the huge cluster, which is on the secondary one. So we want to do an active-active implementation, single source of statistics, and obviously developer productivity is very critical for me. So those are the goals when we started re-architecting the whole stack. So I want to go a little bit more into MemSQL, what are the lessons learned and the design patterns we followed. There's very good documentation on MemSQL docs you can get for more information if you want to go further into the details I shared today. So again, MemSQL is a distributed database which supports in-memory and ColumnStore tables. The cluster we have is 38 machine, which has 6 aggregators and 64 leaf nodes on the 32 machines. It has a high availability, so on any machine you have a master and a slave. So if any point of time one machine goes down, you still have the accessibility to the data that you are trying to access. And in those 6 aggregators, one is named as a master aggregator, where you can call all the DDLs that you want to execute. And the remaining 5 can be used for any DML statements, or also even eligible to run any temporary table creations and stuff. So at a high level, it's a distributed database. So even before committing to MemSQL, we want to make sure this platform can scale to our use cases, right? So what we have done is we pick one of the pipelines which has huge ingest needs, and the calculations are running longer as well. So what we have done, we done a benchmark of loading 1 month full data on it. And some of the benchmarks here is that the legacy database is taking about 400 minutes, and about 15 minutes MemSQL is able to load them. In that 15 minutes, there was some serial processing of MD5, some calculation on the files. These are huge files. So there is a lot more efficiency can be done there, but at this point, the benchmark is 15 minutes. And the calculations that we performed on this huge data set is 95, which is very resource intensive. It's almost like having all the customers' data every 5-minute sample in a hash on and picking the 95th sample of it. So we have benchmarked the calculation as well. On legacy, it was taking about 55 minutes. On MemSQL, 2 minutes. So these metrics convinced that yes, this could scale to the needs that we are looking at. So in Q2 2018, we went live, and we started working on rest of 37 pipelines porting onto MemSQL. And after that, you can see that the data growth, as we saw 13x data growth, has came onto MemSQL database. But still, you can see the trend of process time coming down, because as we port more pipelines onto MemSQL, the process time came down. And we are predicting to get it even further down with the enhancements in plan, even though there is an exponential growth in the data volume. Right. So as I said, ingest scaling is very critical for NSE to scale project. So MemSQL has a built-in component for it, and it's like a pipeline extraction, transformation, and loading without any need of any middleware or any third-party tool, since it makes use of the distributed cluster you have, and it can scale, and it's very high performant as well. And it can support file systems. It could be as simple as any CSV files or anything like that. It can support Kafka, STFS, Amazon S3, Azure Blob. Our use case here is a file system. So again, I mentioned before that we have 240K edge servers around the world. So that generates petabytes of logs. So our upstream system scraps all the logs, aggregates data at a 5-minute level, and publish them or push them to our NFS mounts. MemSQL just look at the NFS mount and does ingest for us. So in MemSQL pipeline, you have a transformation logic which you can write either on Python or MemSQL procedural language. So what we have done, our use case here is we have used Python to see whether the data is considered as a billing data or late data, because we finalize at a month end. As per the SOX compliance, we should not bill on late data. So in legacy database, we used to archive data manually. That used to take about 8 hours at the month end, the whole close stops. But with the newer implementation, there is no wait needed. It's just a simple execution of a script, and we are ready to go to the next month. And this helps us to go on to Kafka in future. That's what we are planning to go away from file system based on our upstream implementation. So now we have a scalable ingest, but we still need to determine whether we're going to use a RowStore or ColumnStore. So we did a POC on it as well. We've seen 30 to 40% degradation in ingest and query performance using ColumnStore or RowStore on large pipeline data sets. But the scalability factor and 90% compression element of ColumnStore is a huge factor for us to pick ColumnStore as of pipeline-based tables. And as we use this use case more and more, we realize that ColumnStore suits analytical workloads very well. So if you guys are into that, look at ColumnStore. Obviously, just a brief explanation, RowStore always on memory, ColumnStore resides on the disk. So one of the example of 37 pipelines I have given, like 2 tables, which are close to 1.2 trillion rows there. The ColumnStore usage is about 34 terabytes, which includes high availability as well. That means it has a slave and a master copy. That's huge scalability factor. Again, since this is a distributed cluster, sharding is very, very critical. And we got to make sure that skew is less than 10%. If you don't shard it right, you might end up overloading one of the nodes, and that could become your bottleneck for any query performance or ingest that you're doing. So if you insert anything into MemSQL, it looks at the shard, what you have defined, and pushes to the leaf nodes. So I have given an example. One of the table has a start time column in it, and it has customer user ID, traffic type, country code, and those are the columns. But if we just shard with that, it could end up, one high customer could end up a lot of data on single node. So what we have done is we have created a persistent column using that timestamp. And now for every month, the data gets distributed across evenly. And you can see the skew over there is 0.5% to 0.6%. MemSQL recommends under 10%. So that's a very critical. We got to be very critical when we shard tables on MemSQL to get optimal performance. We use temporary tables a lot. A lot of our queries runs on huge data sets. From our experience, we realized that using temporary tables are more efficient than bigger inline queries like using with across all the way. I see a lot of people do that. So that's the lesson we learned. Even for the temporary tables, you got to shard it right. If not, it might end up on a single leaf and cause the bottleneck as well. So I want to give high-level architecture later because I want to explain what MemSQL is, and that's the point. It is little later. So we have 2 clusters. One is primary, one is secondary on 2 data centers. and we only replicate the metadata that was loaded on the primary. Secondary looks at the metadata and loads the files that are coming from our upstream systems. We did this purposefully because replicating all the data coming to one cluster to other cluster is not a scalable way, and the ingest we're gonna get in future gonna be increase more and more. So we thought this is the scalable way to get our ingest replicated across, and it's cost efficient as well. That's good, but now to build an active strategy, you need to have something to control what to do, where the jobs need to run. So in this use case, we need to have 24 months of active data online for any credit and rebill. So at any point of time, last 23 months should match data on both the clusters. So Airflow as a controller, if it is running for the previous months, it will fan those jobs onto secondary cluster. But for the current month, all runs on the primary cluster when we have active turned on. I'll go more into Airflow after this slide. Right. So Airflow is an open source platform to program and create, schedule, monitor workflows. You can create a workflow with DAGs. DAGs are written in Python language. Airflow schedules executes these tasks on an array of workers while following specific dependencies. It supports distributed task execution. Obviously, workflows can be maintainable, versionable, testable, and collaborative as well. Some of the components on Airflow is that you have a scheduler and executor where the decisions made and where it decides to fan the jobs. Workers are the workers, obviously, for the jobs you are trying to do. And there's a web UI to see what's happening on the Airflow. And there's also metadata that you can access to have the historical data as well. And we tapped into it to use it in Prometheus as well. I will show the use case there. And obviously, every task has their own logs that you can look into. So if you remember the high-level architecture, all the workers are deployed onto the master aggregators as of now. So at a high level, I mean, it's good to know the dependencies of each functionality that you are executing. I purposefully kept this at this level so that you guys don't know what you are exactly looking at. But so you can, for anybody who's stepping into the team or any BAs who wants to know what's happening, what are the dependencies. So visual here, you can't miss it. You can understand what's the dependency of each task. And it gives you live feedback, like what is running, what failed, what skipped, what is on the retry, what's on the queue. It's a pretty good way of looking your functionality, what's happening on a job that's executing. As you know, you can put how many retries a job can take, and you can put some slice how much time it can take before it can run. And it also, you can say, only don't email me on a retry, just email me on the last retry if it fails. So it just performs by itself. It just takes care of issue. If it's an intermittent issue, you really don't know that the issue has been taken care of. So this is a graph view of the job, and you can peek into previous jobs as well at the same time, see how the previous job, what functionality it ran. And it's all historical metadata that it can go and show you on the front end. There is a tree view. Tree view gives you a heat map of your functionality. Obviously, if we are running on a shell script or anything like that, you got to go into log files, and we have done this. It's not a way of supporting these big data applications at this point of time. So it gives you a heat map of what functionality is being actively used right now. So if you see some task has been skipped for last 100 runs, that means that the functionality is not being active. You can either refactor your code or ask so these all runs by the contract setup. So something probably wrong in the contract that BSS can reach out to upstream contract setup people to fix that. So it's a good way of looking at how functionality is doing on the day-to-day process. So the one on the left, the one on the left is the batch that runs for all customers. The one on the right runs for subset of customers. So you see that some of those jobs are, it's not that all customers are using all the products. So you see some of those are skipped, and that's the reason why that. And there is a task view as well. Now, this is a custom built for MemSQL. We did few changes to Airflow to show aggregator, host names on the tasks where it's getting executed. It's very critical. Sometimes what happens is that you got to make sure you give the same grants across all the aggregators. You can't just give one and say it's all good. So you might end up failing on one aggregator. And if you don't know where to give the grants, it becomes so hard to support. So that's what we did. We have, on the host names, you have aggregators where it's exactly getting executed. You can set some priorities on the pools. You can create small tasks, big tasks, medium tasks, and say what parallelism you can run. And you can see the queues. So our primary queue is core site. Our secondary queue is Dallas. That could change any time. But you can see where these jobs are getting executed. And you can also see retry, how many retries it took. But there's probably a bug there that's showing for minimum it's showing 2. So we will fix that later. And you can also access the logs of the tasks that executed with easy click on the front end rather than going on to servers and looking at the logs. And this helps to operationalize. You generally follow tier 1, tier 2, tier 3 support. As operational people get more comfortable with the front end and knowing where to look at, what to look at, it makes it easy for support an enterprise level application. And this helps us because today tier 2, tier 3 is all developers that are stepping in because it's so complex for people to go on to several servers to look at the logs. This becomes easy, and as they get more experience, they would also handle tier 2 support, and that would help a developer support getting down there. All right. So again, Airflow is kind of a framework. Like you can compare to web frameworks. Not compare, but if you take Django, it's like a web framework or Flask. Airflow is for scheduler and workflow manager. So you can build your own plugins on it. You can extend its functionalities. So what we have done is that since we are doing active, we want to know how many workers are being active, what jobs are running on those queues. So we have built a plugin. If you see on the top, you see core site and Dallas being active. And you can see the workers, what are active and how many jobs are running on each worker. And also you can extend the template, build your own report. So we have built a request status report where you can see what's happening. With a single click, you can go to the job as part of that job execution. Some of these jobs are executed by support for customer billing questions, and we have given them access to submit a payload and easy access to download stats as well. So it used to take about 3 to 4 days to even get the customer data previously. Now it would happen in hours, I believe. So that's a big process improvement we have done using this platform. It's one place for everybody to look at and support the application. Again, now we have close to 38 servers and per cluster. So we have 2 clusters. How do you monitor them? How do you forecast your usage? How do you kind of figure out what are the bottlenecks? Which server is causing the bottleneck in any performance issues? So we looked at Prometheus and we implemented it. It's a powerful data model and a query language that lets you analyze how your application and infrastructure are performing. If you remember, on the Airflow, you have a metadata, so you can tap into that as well by bringing all the server metrics and see how application is impacting the cluster consumption. So Prometheus had something like a node exporter that you can deploy on all the servers that you have on the cluster. Basically, what it does is it has a web page where it on 9000 port where it publishes all the metrics of that server every 5 seconds. And Prometheus goes and scraps these pages and inserts into a table. So you have all the historical data of the cluster servers that you have. And there is also an alert mechanism where you can set if the usage is more than 60% of cluster capacity, send an alert. And this can be, it's not real time, but it helps. I mean, when you have a cluster of this size, it helps to at least have something that alerts you within 5 minutes of the event happen. And obviously, Grafana is used for historical data that happened on the cluster usage and stuff. So at a high level, this is what we have right now, and this keep on changes as we want to understand more about MemSQL and how application is impacting MemSQL behavior. At a high level, you can see what's the CPU usage for last 7 days, or you can go historically as well. I'm just giving an example of 7 days here. So you can look at how what is the available memory, and how many processors are being used and stuff like that. But if you see, there is a pretty big CPU usage on September 17th. You can easily peek into that and see what caused it. Now we have metadata of Airflow that we can tap into as well. So if you see that I have selected Airflow tasks, and one of the geo calculations are running, which is very resource intensive. This is expected behavior, so it's fine. But if you don't see anything like that, there's something wrong with the cluster. So it's one way of looking at how your application is using the cluster, and is the anomalies are fine, are expected by getting everything in a one view. Now, obviously, memory usage view is very critical because MemSQL has a RowStore, which is almost all of it on RAM. So you got to be very careful on what is the forecast of your RAM usage. The memory is used for temporary table creation or any query that is running. So you got to know what's the max memory used on each machines. You can see any outliers that are happening and fix that. We have seen a case where one of the DIMMs went down and the machine memory came down. So historically we have looked at it and fixed it. So we will set up alerts in future to track it right away. But this gives you a view for you to forecast if you want to scale your, obviously if you are getting more ingest and you want to increase your RowStore capacity, you got to add memory, and this helps you to forecast that. And also see any anomalies that is happening with your application. Right. Again, this is a network usage, because if you are obviously if it is a cluster, there's a lot of chatter happening, a lot of repartitioning happening within the MemSQL cluster. And you can notice any outliers. If you not sharded your table right, you will see those outliers here. So this is one way of looking at your table creation for big data sets, if it is impacting or bottlenecking any ingest that is happening. You can also, so bond 0 is all internal chatter and what is connected to the NFS mount. Bond 1 is the backend for backups. So you can see how backups are running, what kind of network usage it is doing. If you want to increase network, you can see historically and plan for any future needs. Obviously, disk I/O is very critical as well, because ColumnStore is all on disk. And again, you have this view of seeing some of these are expected behaviors. But if you see outlier, like I see a big purple line, then I peeked further in and I see one of the big tables are getting loaded, and that's obvious. But if I don't see anything, and if I see the spike constantly while this file is loading, that means that the table is not sharded right. So you got to figure out the strategy to shard it right. And that's what it provides, the application behavior on the cluster in a single view. Obviously, this is all good. So many stacks here, a lot of binaries to control and build applications, right? So how do you make it easier on you to have this stack? So we have choose to containerize a lot of Airflow and Prometheus. Obviously, most of you guys know Docker is designed to make it easy, deploy and run applications by using containers. You just build once and deploy to any Linux machine out there, and you don't need to worry about you having dependencies available on the server. So we have used Docker to containerize a lot of our stack. And it also gave us flexibility to create our own tool. Like it is, we are able to create an application development kit where developers can create their own dev environment in their own laptop. We also Dockerize MemSQL, and MemSQL also started publishing a Docker image now. So we are able to create the whole functionality of the stack on any Mac, PC, or Linux or a Linux server. You really don't need internet access to even work on any of the functionality that needs to be built. We named it as now, since we have the power of able to run on any machine, we went further and created a new framework called BBox, which is black box testing, which is used as a regression tool. We internally use Robot framework for that. This is very handy tool because if any newcomer comes, we can say, just take this, you can run on your own laptop, see how things are working, because that's how people learn, right? So it's a very handy tool for developers, QA, BAs to make sure that regression test cases are not affected with new requirements or check-ins. This tool is created to implement continuous integration. It's very lightweight when compared to the big cluster out there. It's almost like a 10 GB footprint. Obviously, this enables developers to work on their own machines, and we want to use this to validate any check-ins that are happening on our stash, and then forward the changes onto dev machine based on if all the regression testing is passed. At a high level, I have a positive and negative scenario. If so, the one on the, I don't know whether it's right or wrong, right or left, but the green one is the where the build passed. You can see it is divided. All the functionality is divided by suite. So if everything was able to match, you can forward the build onto dev cluster using Jenkins. If it fails, we can email the developers. We haven't done that yet. That's our future enhancement that we want to do, but we have tool to do it. Some of these tests are run on a small machine, so you see this ran around 1 hour, but we want to get that time to like 10 minutes on a bigger server and get this going for us. And talking about future enhancement, obviously we want to go away from big file loadings. We want to use Kafka, ingest data into MemSQL pipeline supports it as well. So we just need to change from file-based loading to Kafka-based loading. And we also want to include Flink as part of the stack to calculate some of real-time statistics, and any historical needs we will use MemSQL and for the data store and graphical representation purpose. We want to move away from Docker. We want to use Kubernetes and Openshift, where our platform team is more comfortable using that and they have license for it, and that's the reason why we want to move to that. And obviously, as you mentioned, we built BBox for continuous integration purpose, and we want to enhance that and use it. Again, rate today's session, and just go to conference website and Orally event app to rate this. This is my LinkedIn profile. You guys can connect me over LinkedIn as well. Now I'm open to Q&A. I hope we have time here. Yeah, we do. Yes.
I have a question. So you showed how you monitor network traffic. So I'm assuming that you're averaging on some period. So do you have anything on your platform where you can measure short outbursts of network activity and then alert you?
Sure. See, again, this is all historical data. Even the scrapping of these logs done every 5 seconds, because it's reaching out to 38 machines. So it probably will not do it. If it's able to catch in that 5 seconds, it might, but I don't think it will give you at the real time. Yeah. Yes.
Is BBox the testing tool, is it open source tool that you guys have, or is it?
No, it's we have used Robot framework, which is an open source tool, and it extends functionality for you to create Jira tickets on any bugs that were created. It is fantastic. BBox is an internal implementation. It won't, it's just a custom application build. So, yeah. Yes.
Did you use Celery, Bash, or whatever for your worker framework?
Yeah. So Airflow internally uses Celery, RabbitMQ, and a lot of other open source components. And that's the reason why we are containerized it. So it's one image that works as a worker, that works as a scheduler, web server, and everything. We just changed the role over there. Did I answer your question there?
Yeah, yeah.
Okay. All right. Yes. Yes.
Can you talk a little bit about your backup strategy? Where you done take this backups?
Yeah. So backup is. Was that? Yes, yes. So she was asking about what is your backup strategy. So at the current version, there is no incremental backups. So we got to make the whole database backup. So our clusters are very big to do daily backups. So our strategy is to backup every month. That said, we are able to recover the whole data of the month in 2 days. So that's what the strategy we have. With 7.0 coming by end of the year, they have incremental backups. So we will backup every day at that point.
So we had a snapshot for each day.
Yes, yes. So it's an incremental backup. So you will just have the snapshot of that. That should make life easier, but still our ColumnStore usage is pretty big. So we are coming up with our own strategy of limiting that incremental backup state by making droplet of databases, like internally partitioning into databases. Because the whole logic runs on Airflow, we can just make them dynamically point to any database we want. Yeah.
Are you guys doing a lot of dynamic tags in your Airflow deployment if you have any advice on that?
Airflow, there is a lot of, it can behave based on whatever you are trying to do. We have a pipeline controller. So it looks at one of the driving tables to figure out what DAGs to run and what DAGs to skip. Not DAGs, but what tasks to run, what tasks to skip. So you can do it dynamically. It can behave. So you can see the skipped. That's what I showed you in the heat map. You see, I've seen some of them skipped. And you can do that too. Yeah. Yes.
Are you using Spark within MemSQL?
No. Spark is used to get data from MemSQL and do some ML to figure out trends. And I think we use FB Profit to figure out any trends and anomalies. And we ingest data back to MemSQL, and Grafana connects to MemSQL to graph it for the end users. That's a question.
Why are you moving out of Docker or away from Docker?
So it's more like the platform team comfortability there. They have a licensed enterprise level they are using for other teams. So we want to give the support back to, we are supporting our own Docker. We really don't want to support it and want to go with the general platform support and nothing beyond it. Docker is doing pretty good. It's nothing against that. It's just that aligning with the other teams. Any more questions? We have 3 more minutes. Yeah. Yes. So definitely not production data, but when the artifacts have been created for robot framework, what we do is we create different types of combinations or the permutation combinations of the contract, and we get the base data as part of the artifacts as well. So it is like hitting all the functionality, what we have written for, but it's probably, I would say, 0.1% of the data that we have on prod cluster. That makes it more lighter to run on small machines. Yes?
So you talked about creating temp tables and leveraging temp tables. So did you come across the performance degradation at some point? If so, with the underlying joins, right? Not using temp table and if you're directly using the joins, what is that threshold that you reach? 30 tables, 50 tables, how many joins?
Yeah.
Data volume?
It's definitely data volume. Our joins are, obviously you have a contract data set and a customer user ID data set and the large table that you are looking at, right? So our joins most likely 3 or 4 or 5 max. At max, if you're trying to figure out what country belongs to a geo, right? But I think the fact is that if you are trying to access, some of our joins hash joins have close to 400 billion records. So it's not efficient to put that on a width where you don't know how that's gonna shard, right? Then you're gonna end up repartitioning the data for the next access of the data. So what we do, we know how to set this up upfront, like we partition it right, we shard it right on the temp table, we insert it onto it, then access it for the subsequent join. And
So there's auctions behind it.
yeah, I would take that back. It's a sharding can be defined on the temp tables. Yeah. And we use it very heavily, and we have seen good scaling with that. Yeah. Any more questions? All right, guys. Thank you for coming. Really appreciate it.